Okay, so the next 2 days are going to seem similar to what we did, but the goal for the next 2 days is proving trigonometric identities. So what's going to happen is they're going to give us one trig expression, and it has to be equal to the other trig expression. So you're going to take one side and show that it's equal. So some of the strategies for proving these identities, so always try to start with the most complicated side. So if there's multiplication that you can do, if there's adding fractions that you can do, if it has more complicated trig functions like secant, cosecant, things like that, you want to start on that side. And then you're going to simplify using any of the trig identities, so your Pythagorean identities or things that you already knew like tangent equals sine over cosine. You just have to make sure you show all steps. So proofs mean that you show all steps. You can't guess or have the person looking at it guessing from one step to the next. And then when you finish, you should get the other side of the equation. That's how you know that you're finished. So there's really no reason to miss these. It's just how to get from the start, from one side of the equation to the other side. Okay, so looking at our first example, so like I said, we have this trig expression is equal to this trig expression. We can pick either side that we want to start on, but you want to pick the more complicated side. It will help you a ton. So guys, there are multiple ways to do some of these problems. So if you end up doing it a different way, as long as every step of your problem works, that proof is fine. So looking at this, because I see that this is an equation here, or sine x times our cotangent plus cosine tangent x, because we could actually multiply those two things together, that is going to be the more complicated side. So I always box the complicated side just so I can see where you start, because when you finish you should get this answer over here. So the reason I'm starting here is because we can multiply. So I'm going to go ahead and just multiply these out. This would be sine x cotangent x plus sine x cosine x tangent x. Okay, so I'm only working with this left side, okay? From here on out, when I finish, my answer should be what this says. So because I'm working with sines and I have cotangent, cosine, tangent, I want to change everything to be in terms of either sine or cosine. So this one's already sine, so it's fine, but this is cotangent. Remember, cotangent is cosine over sine. I'm going to rewrite that. Plus, the sine is fine. The cosine is fine. But I want to rewrite tangent, and remember, tangent is sine x over cosine x. Okay, so from here, I can clean this up. So because we have sine in the numerator and denominator, we can cancel those out. So I'm just left with cosine x here. Plus, over here I have cosine in the numerator and denominator, so I can cross those out. I'm left with sine times sine, which would be sine squared x. So, if you take a look, this answer is exactly what we were supposed to show that it's equal to. So we have finished our proof. We've shown all the steps that we need here, and we've got to our final answer, which was on the right side of the equal sign. Okay? So that's how you show that you're proving a trigonometric identity. So moving on to the next one. Okay, so remember we're trying to pick out the more complicated side to start out with. So this is similar to the last one because I see that this whole thing could be squared and we could multiply that out. This is the more complicated side. So once again, because I see this multiplication here, that's going to be more complicated. So I'll just write these out twice so you can see for us to multiply. Okay, so squared is the same thing as having a written twice. So if we use FOIL to multiply this out, we'll have cosine squared x minus cosine x sine x. Then we have another one here, minus sine x cosine x. And then we would have plus sine squared x. So just use FOIL to multiply it out. So these are the same terms here. Okay, just written in a different order. So I could combine those two terms. So cosine squared x minus 2 cosine x sine x. And then plus sine squared x. Alright, So remember, we have to make it look like this. 1 minus 2 sine x cosine x. So this part right here, I really have here. It matches. I just need to rewrite it in the right order, which is fine. So somehow I need to get a 1 out of the rest of it. So if you're looking, we have this cosine squared and we have sine squared x. Remember, cosine squared plus sine squared is equal to 1. So that's where that 1 comes from. Okay, write that over here just so you can see what I just said. But cosine squared plus sine x equals 1, so that's where I got the 1 from. And then I want this to look exactly like the side over here, so I'm going to rewrite this in the right order. So I'm going to have 2 minus 2 sine x cosine x. So now this looks exactly like the right-hand side of that equation, which is what we were supposed to make it look like. Alright. Then if we move on to the next one. So for the next one, we have tangent x plus secant x equals cosine x over 1 minus sine x. So for this one, there's not any multiplication, so that's not going to help you figure out where to start. There is like division over here, but you can't really divide cosine divided by 1 minus sine x. So in this case, you want to pick the more complicated trig functions. So guys, more complicated are like the reciprocal trig functions. So tangent and secant are more complicated than cosine and sine. Okay, so that's why I want to start over here. So I'm going to rewrite these in terms of sine and cosine. So tangent we know is sine x over cosine x. And secant we know is 1 over cosine x. Okay, these are two fractions, so you would want to add the two fractions together. They actually already have the same denominator. A lot of times they don't, but if they have the same denominator, you're fine. So you can just add the numerator. So this is the same thing as sine x plus 1 over cosine x. Okay, so take a look at what we have and take a look at what we're trying to get. This happens a lot with trig identity, so you want to kind of spot this out when you see it. But what's happening here is, if you notice, like the cosine is in the numerator here, but the denominator here. And then the sine x and the 1 is switched. So they're flipped. It needs to be flipped. Also, this says 1 minus sine x, whereas this says 1 plus sine x. So we really need it to be a negative there. Okay. So what you're going to do if this happens, you can take the one that says the sine x plus 1, and you can multiply by what's called the conjugate. So instead of sine x plus 1, I'm going to multiply it by sine x minus 1. What it is it's the same thing as it looks here. It just has a subtraction instead of addition. Okay, so I'm going to multiply this out. So if I were to multiply these two things together, because they're conjugates, it would be sine squared x minus 1 in the numerator. And then I'm not going to multiply out the denominator. I'm just going to leave it like it is right now. Okay, so if you remember your Pythagorean identity, so over here on the side, we know that sine squared x plus cosine squared x is equal to 1. So I want to rearrange this so this says sine squared x minus 1. So if I move the 1 over, then I would have to make this negative cosine squared x. So this numerator is really the same thing as negative cosine squared x. And then I'm just going to keep my denominator the same here. So because I have this cosine squared x and this cosine, I can cancel out this squared and that cosine. So I have negative cosine x left in the numerator over sine x minus 1. Okay, take a look at what we're supposed to have. We're supposed to have cosine on top, which we do, but it's negative, and sine x minus 1 on the bottom. Similar to what we have, but it's flipped around. So all the signs are changed. So what I can do here is, if I want to get rid of this negative, I can factor out, I'm going to keep this negative here, but on the bottom here I can factor out a negative and make this be 1 minus sine x. So then I can cancel out my negatives. So finally I'm just left with cosine in the numerator and 1 minus sine x in the denominator, which is what was on the other side of the equal sign here, which is what we were supposed to get. So, couple things I just want to reiterate here. So we started on the left-hand side this time because sine and secant are more complicated than cosine and sine. Okay, we didn't have any multiplication. So that part was pretty easy. But when you got to this step where you have this sine x plus 1 over cosine x, but this is what we want to have. It's flipped, so it's like the reciprocal of it, and the sign is wrong here. You're going to multiply by what's called the conjugate, and it will pretty much always take you through these types of steps, and then you should be able to end up with your answer.